Hello, I'm Reggie York. This is a presentation on using a special Excel file when you're doing the chi-square test. I'm University of North Carolina, Wilmington. This is what this presentation is about. It's an illustration of how to use a special Excel file that I have created to make it simple to use the chi-square test. The chi-square test can be used for the examination of the relationship between two dichotomous variables, meaning a dichotomous variable means it has only two categories. Chi-square is often reported in the literature with the letter X square. I'm going to use an example. You're comparing two groups on the basis of whether the client improved. That means simply yes or no. Another example, you may be comparing the proportion of favorable treatment recordings to the proportion of favorable baseline recordings for a single client. If you're using the AB single subject design, you may have behavior measured as a dichotomy, meaning the client did or did not perform a task or something like that. And you measure that several times at a baseline period before treatment begins, then continue to measure it several times during the treatment period, and you're comparing these data. In the example we'll use here, we're talking about two groups of people. What you need is this special file that comes with this particular book. You need your own data if you're going to use it. That is to say, you have the number of people in group 1 who had favorable results, and the number of people in group 2 who had and the number of people in group 1 who had unfavorable results. The same for group 2. In other words, for group 1, favorable, how many were favorable, how many were not. Group 2, how many favorable, how many not. Here's what it looks like in a table that I would suggest you put together for your own data before using this file. As you can see here, the question, did the client improve, yes or no? For the treatment group, 10 persons improved, 3 did not. That's 77% of the treatment group got better. For the comparison group, 6 people got better, 12 did not. So only 33% of this group improved. So this means that the treatment group did do better, but the question for statistics is whether this difference is statistically significant, or that is to say, not easily explained by chance. Here is the hypothesis. In this case, those in the treatment group will be more likely to improve than those in the comparison group. If you're using the AB single subject design, the hypothesis might be the proportion of favorable recordings in the treatment period will be greater than the proportion of favorable recordings in the baseline period. This is what we get after we see our data: the value of chi-square, the value of phi coefficient, which is a measure of the strength of the relationship between the two variables and the two groups, and can be used for examining the question of practical significance. You get information on whether the particular chi-square value is significant at the 0.10 level, or the 0.05 level, or the 0.01 level. You can always look up the value of chi-square in a table of statistics to get more information. One caveat: if any of the values that appear in the major cells are less than 5, that's when you're entering your data, then chi-square is not an appropriate statistic. The Fisher-Exact probability test would be an appropriate alternative. Now let's look at the file, the special Excel file. Here we have, if you'd like to pause and read these instructions, you can do that right now. Okay, I assume you have now come back with me after pausing and reading those instructions. Basically, as you see, we have a treatment group in this column, comparison group data in this column, And the question over here is yes or no. In our case that we're illustrating, the question is, did the person improve? Our data showed that 10 persons in the treatment group improved and 3 people did not. For in our case that we're illustrating, for the comparison group, 6 people improved and 12 people did not. Now let's look at the value of chi-square, which is right here, 5.74. This is the value you can use to determine whether statistical significance was achieved. Here you have an indication that a chi-square value of 3.84 or higher is significant at the 0.05 level. The chi-square value of 2.7 or higher is significant at 0.10 level. And a chi-square value of 6.6 is significant at the 0.01 level. We did not achieve 0.01, but we did achieve 0.05 because 5.74 is higher than 3.84. So this chi-square value achieved a p-value less than 0.05, the normal standard in the social sciences. Here are expected frequencies. In our particular case, none of these has a value lower than 5, so our data is okay. It is okay for us to use the chi-square statistic. So our data showed that the treatment group was better than the comparison group, and it was statistically significant. So the hypothesis is supported. I hope this helps. Good luck with your own work.